Hi, I'm audible. Students, audible. I'm audible. Students. Hi, hi, students. Nandini is from Goscore Learning Center. We are the fastest edit company GCs. Students, electromagnetic induction. So discuss about the chapter electromagnetic induction part 1. So chapters first of all the of chapter 6 electromagnetic induction. Next one field magnetic flux again magnetic electromagnetic induction. What are the experiments done electromagnetic induction? Next one is second and induced charge and change in magnetic. This all be thoroughly. Okay, first introduction about this chart. So we know that Ost discovers the Faraday and Henry also something. In third here, change in flux induces the EMF. It is inducing. I'll explain in this chapter. First of all, what is the magnetic field? What is the field? Chapter 50 we start. Repeat what is the magnetic field. So, space around the magnet up to which it can be attracted. That is a magnetic field. B. You know, right? Example, trans here. Why? Because up to certain area, the magnetism is up. It is not attracting. Field lines is here. It is attracting. It is not attracting. It is not around the magnet up to which it attracts magnetic material. Space we call as a. That space we called as a. Hello, hello, hello. I'm audible. I'm audible. I'm audible. I'm audible. Hi, friends. I'm audible. I'm audible. Sorry. What is around the magnet up to which it can be attract magnetic material? That area we call as a magnetic field. Uh, then it is attracting. Here it is not attracting because here there is area. This area we call as a magnetic field. This area for magnet. What are the poles? South Pole. What is the direction of South Pole? North Pole to South Pole. Inside the magnet, what is the direction? South Pole to North Pole. South Pole to North Pole. So here I am taking one iron piece. Here I am taking one iron piece. It is a iron piece. It means it is a magnetic material. It is a iron piece. It is a magnetic material. Then the magnet is attracts. Then the magnet is attracts the magnetic material. It means up to the certain area. Up to the certain area, magnetism is occurring. This area we call as a magnetic field. This area we call as a magnetic field. Now I am taking this iron piece here. What is happening? The magnet is not attracting the iron piece. Why? Here there is no magnetism. Here there is no magnetism. That's why it is not attracting. Here only the iron piece is there. Here or here. In this particular area, iron piece is anywhere. It will be attracted because up to the certain area only magnetism is there. That's why magnetic material is attracting. That's why magnetic material is attracting. This area, this total area magnetic lines we called as a magnetic field. Then you understand guys what is the magnetic field. So the space around the magnet up to which it can be attract magnetic material, that we called as a magnetic field. That we called as a magnetic field. Magnetic field is indicated by B. The magnetic field is indicated by B. Symbol B. Then what is the units of magnetic field? What is the units of magnetic field? The units of magnetic field is Tesla. What is the units guys for the magnetic field? Tesla. Tesla is the units of the magnetic field. Tesla is the units of the magnetic field. Next one. Magnetic flux. What is the magnetic flux? Magnetic flux is indicated by 5. Magnetic flux is indicated by 5. What is the definition of the magnetic flux? Number of magnetic lines of force passing through the particular area that we called as a magnetic flux. Number of magnetic lines of force passing through a particular area that we call as a magnetic flux. I am taking one particular area. I am taking one particular area. I am taking, it is an area. So for this particular area, I am taking a one magnet near to the particular area. Then from that magnet, the magnet is producing the magnetic field. The magnet is producing the magnetic field. That magnetic fields are passing through the particular surface area. That magnetic field lines is passing through the particular surface area. See. So these all are magnetic field lines. These all are magnetic field lines. These all are magnetic field lines. But in the particular area, some of the magnetic field lines are passing. Remaining magnetic field lines are not passing. So in this particular area, how many magnetic field lines is passing through the particular area? That magnetic field lines we called as a magnetic flux. Simple thing. In this area, how many magnetic field lines is passing? Some magnetic field lines only passing. Remaining is not passing. So this in this particular area, how many magnetic field lines is passing through it? That magnetic field lines we call as a magnetic flux. So you understand, guys? So this magnetic field lines we call as a magnetic flux. This magnetic field lines passing through the particular area. So this magnetic field lines we call as a magnetic flux. These only magnetic field lines is passing through the particular surface area. That's why these magnetic field lines we call as a magnetic flux. So number of magnetic lines of force passing through the particular area we call as a magnetic flux. That magnetic flux is indicated by phi. That magnetic flux is indicated by phi. Then what is the formula? What is the formula? From the definition, what is the formula, guys? See what we are using here, magnetic field, surface area. From this only we are getting the equation. Simple. What we are using? Magnetic field, surface area. Then what is the formula? Flux phi is equal to product of magnetic field into surface area. Simple. Flux is equal to product of magnetic field and area. Product of magnetic field and area. Then what is the one question is there? Which type of, here we are using vector or dot? Which type of product we will use here? Vector product or dot product? How we will find out that? Simple thing, guys. I am taking here surface area is this direction and magnetic field also this direction. Then I am taking surface area and magnetic field both in parallel. Magnetic field and surface area both are in parallel. Then what is the theta? What is the angle between the surface area? What is the angle between the surface area? What is the angle between the surface area and magnetic field? What is the angle between the surface area and magnetic field? Theta. Theta is equal to 0 degrees. So the angle between the surface area and magnetic field is 0 degrees. Then I am taking flux is equal to vector product. It means what is the equation, guys? B into A sin theta. For a vector product, this is the formula. Phi is equal to BA into sin theta. Then substitute theta is equal to 0 degrees. Here area and magnetic field are in parallel. That's why theta is equal to 0 degrees. Then phi is equal to BA sin 0. What is the sin 0? 0. Then the product also 0. Here we are getting flux value is 0. It means we will use the vector product, flux is 0. Here we are using the vector product, then flux is 0. That's why we will use here dot product. Here we will use dot product. Then what is the dot product? I am taking again surface area. It is a surface area. It is a surface area. Always surface area vector is perpendicular to the surface. Area vector is always perpendicular to the surface area. Always vector area is perpendicular to the surface area. It is a area vector. Then I am taking magnetic field lines. So for this area, so many magnetic field lines are passing. So in that magnetic field lines, I am taking one magnetic field line. So like this direction is there. I am taking like this direction. This line is magnetic field. It is a vector area. It is a vector area. For this two, some angle is producing. For this two, however, some angle is producing. It is, I am considering it is a orientation is indicated by theta. This orientation is indicated by theta. Then what is the dot product? What is the dot product of the flux? Flux is equal to B into A cos theta. B into A cos theta. This is the dot product of the flux. So here I am taking always area vector is perpendicular to the surface area. Magnetic field lines is passing through the surface area. In between the area vector and magnetic field, some angle will be producing. That angle I am considering here as a theta. I am considering as a theta. Then phi is equal to BA into cos theta. BA into cos theta. It is a dot product. It is a dot product. Then some special cases is there. Then we are taking the theta is equal when we are getting the maximum flux. When we are getting the maximum flux. So theta is equal to 0 degrees. Theta is equal to 0 degrees. It means area vector and magnetic field both are in parallel. Both are in parallel. Theta is equal to 0 degrees. Theta is equal to 0 degrees. Substitute the theta here. Phi is equal to BA cos 0. What is the cos 0, guys? 1. Then phi is equal to BA. So, when the area vector and magnetic field lines both parallel, at that situation we are getting the flux is maximum. Flux value is maximum. Flux value is maximum. So, at a parallel condition, we are getting the maximum flux. We are getting the maximum flux. Okay, understand, guys? So, what is the flux? What is the flux? Flux is equal to BA cos theta. It is a dot product. It is a dot product. Okay, guys. It is a scalar quantity or anything. It is a scalar quantity. How? Here we are using the dot product. We are using the dot product. For the dot products, it is a scalar quantity. For the dot products, it is a scalar quantity. Then flux is also a scalar quantity. Therefore, flux is a scalar quantity. Flux is a scalar quantity. Flux is a scalar quantity. Then, what is the units? What is the SI units of the magnetic flux? What is the SI units of the magnetic flux? Generally, what is the formula, guys? Flux is equal to B into A. Yes. For the magnetic field, what is the units? Tesla. For area, what is the units? Meter square. So, SI units of flux is for magnetic field it is a Tesla. For area it is a meter square. Tesla meter square is the one of the unit. Another unit is Webers. Another unit of the magnetic flux is Webers. In SI units, two units is the Tesla meter square or Webers. And then what is the units in CGS? What is the units in CGS? In CGS, magnetic flux units is Maxwell's. And one more thing, guys, 1 Weber is equal to 10 to the power of 1 Weber is equal to 10 to the power of 8 Maxwells. Okay guys, so what is the magnetic flux? What is the magnetic flux? Number of magnetic lines of force passing through a particular area. Passing through a particular area. That total magnetic field we called as a magnetic flux. That total magnetic field lines we called as a magnetic flux. So from the definition, what is the formula? Phi is equal to BA. Then it is a vector quantity, vector or dot product means it is a dot product. It is a dot product. For the dot product, what is the equation? Phi is equal to BA cos theta. Phi is equal to BA cos theta. Then here I am taking, when we are getting the maximum value means the area vector and magnetic field lines both are in parallel, then we are getting the maximum flux. Then we are getting the magnetic flux. Then phi is a scalar quantity. Here we are using the dot product. That's why we are getting the scalar quantity. Then what is the units of the flux? In SI units, it is a Tesla meter square or Weber. In CGS units, it is a Maxwells. 1 Weber is equal to the 10 to the power of 8 Maxwells. So you understand magnetic flux. Next one. Flux depends upon the. See, already I draw the diagram. Again, I am drawing. It is a surface area. It is a area vector. It is a area vector. It is a magnetic field. It is a magnetic field. It is a theta. It is a orientation. Then flux depending upon the, we know that flux is equal to BA cos theta. BA cos theta. So here from the equation, flux is depending upon the magnetic field. Flux is depending upon the magnetic field. So in this particular area, maximum field lines is passing through the particular area. Flux increasing. It means flux is depending upon the magnetic field. In this particular area, more magnetic field lines is passing. More magnetic field lines is passing through the particular area. Then what is happening? More lines is passing through the particular area. Flux also increasing. Yes. Then flux is depending upon the magnetic field. Flux is depending upon the magnetic field. It means field is increasing. Flux also increasing. It means it is a proportional relationship. Flux is directly proportional to the magnetic field. It means flux depends upon the magnetic field. First one. Second one. So it depending upon the area also. How? Area will be increased. See guys, I am increasing the area. What is happening? More magnetic field lines is passing through it. More magnetic field lines is passing through it. Then more magnetic field lines is passing through it. Flux will be increased. It means flux is proportional to the area of cross section. Area of cross section is surface area is increasing. Magnetic field lines passing through the surface area is increasing. Then the magnetic field lines is increasing. Automatically flux will be increasing. And one more thing is there. Third one. Flux is depending upon the three values. What is the third one, guys? See, check here. What is the third one? Orientation. Orientation is depending upon the theta. depending upon theta. So angle between the area vector and magnetic field also flux will be changed. Already we observe theta is equal to 0 degrees. Theta is equal to 0 degrees. We are getting the maximum flux. Theta is equal to 90 degrees. What is happening? Theta, cos 90, 0. Then flux is also 0. It means flux is depending upon the orientation. Angle, flux is depending upon the angle. Then what is the relationship? It is proportional relationship or inversely proportional ship. So flux is inversely proportional to the theta. For 0 degrees we are getting the maximum value. For 90 degrees we are getting the 0 value. It means inversely proportional. Flux is inversely proportional to the theta. Flux is inversely proportional to the theta. So flux is depending upon the area vector, magnetic field and theta. But flux is directly proportional to the area vector. Flux is directly proportional to the magnetic field. But flux is inversely proportional to the theta. Flux is inversely proportional to the theta. Okay guys. Next one. When we are getting the positive flux, when we are getting the zero flux, when we are getting the negative flux, it depending upon the theta value. It depends upon the totally flux is depending upon the theta value here. So theta value will be changed, the sign also changing, positive or zero or negative. So theta value like this, it is a 0 degrees. So theta is greater than or equal to the 0 degrees or less than the 90 degrees, we are getting the positive flux. Theta value is greater than or equal to the 0 degrees or less than the 90 degrees, we are getting the positive flux. And in another condition also, theta is greater than the 270 degrees or less than or equal to the 360 degrees, we are getting the positive flux. Already this one is proved. This one is proved. At 0 degrees we are getting the BA. It is a positive flux. BA, it is a positive flux. Then when we are getting the zero flux, already this one also I explain. At theta is equal to 90 degrees, we are getting the zero. Cos 90, how much guys? 0. Then the total product is also 0. At theta is equal to 90 degrees, we are getting the flux value is 0. In another condition also, theta is equal to 270 degrees. In this condition also, we are getting the zero flux. Next one, negative flux. When we are getting the negative flux, when we are getting the negative flux, theta is in between the 90 degrees and 270 degrees. Theta is in between the 90 degrees and 270 degrees. We are getting the negative flux. So you understand guys? So totally flux depending upon the angle between the area vector and magnetic field. Theta is greater than or equal to 0 degrees, less than the 90 degrees, we are getting the positive flux. Another condition, theta is greater than the 270 degrees and less than or equal to the 360 degrees, we are getting the positive flux. When we are getting the zero flux, theta is equal to 90 degrees, theta is equal to 270 degrees, we are getting the zero flux. Next one, when we are getting the negative flux, theta value is greater than the 90 degrees, less than the 270 degrees, we are getting the negative flux. Then you understand guys? Okay. Next one, what is the dimensions? What is the dimensions of the flux? We know that guys, one formula, F is equal to B I L. Force is equal to magnetic field into current into length. So I need magnetic field dimensions now. B is equal to F by IL. F by IL. What's the force units? What is the force units, guys? M L e to the power of minus 2. So force units M L t to the power of minus 2. For current, what is the units? Amperes. That's why I am taking dimension also A. It is a length. That's why it is L. It is L. Then here L is there. Here L is there. It will be cancelled. Then finally we are getting here magnetic field dimension is M1. It is N1. It is 1. It is 1. Then M1 LL cancel, then we are getting t to the power of minus 2. Here a comes to numerator, it is a to the power of minus 1. It is a magnetic field dimensions, but we want flux dimensions. It is a magnetic field dimensions, but we need flux dimensions. We need flux dimensions. Then what is the formula, guys? Flux is equal to B into A. What is the formula? Flux is equal to B into A. Then we know that now magnetic field dimensions. What is the dimension? M1 t to the power of minus 2 a to the power of minus 1. For area we know that what is the dimensions? L square. What is the dimensions? L square. Then what is the total dimensions? Flux dimension now. Flux is equal to M1 L to the square t to the power of minus 2 a to the power of minus 1. These are the dimension for the magnetic flux. These are the dimension for the magnetic flux. So you understand, guys, what is the dimension for the magnetic flux? So M1 L to the power of square t to the power of minus 2 a to the power of minus 1 is the dimensions for the magnetic flux. Next one. First, I will explain about the Oersted what discovered, Faraday and Henry what discovered. So we know that Oersted discovered any wire is in any wire current is passing through that wire. Then what will happen? Magnetic field will be producing through the wire. So I am taking one wire. See. So this wire is, in this wire current is passing through it. Then Oersted discovered for this electric wire producing the magnetic field. Any electric wire is there, in the surroundings magnetic field will be producing. He discovered like Oersted discovered in any electric wire, any electric wire current is passing through that wire, then that electric wire produces the magnetic field. Then electric wire is produces the magnetic field. What discovered Faraday and Henry? Exactly opposite, guys. Exactly opposite. Here from the current magnetic field is producing. Here Oersted discovered from the current magnetic field is producing. From the current magnetic field is producing. But here from the magnet EMF and current is producing. Faraday and Henry discovered from the EMF, from the magnet from the magnet, from the magnet, EMF and current is producing. From the magnet, current and EMF producing. Oersted discovered from the current magnetic field is producing. Henry discovered from the magnet current and EMF is inducing. So both is related to the EMF and magnetic field. Both are related to the EMF and magnetic field or current and magnetic field. Both having similar quantities is there. Here current is there current is there. Here magnetic field is there, here magnetic field is there. What is the difference? Oersted discovered from the current magnetic field is producing. Faraday and Henry discovered from the magnet EMF and current is inducing. That is the difference. Next. Electromagnetic induction. Electromagnetic induction. So, all those things discovered Faraday and Henry. Faraday and Henry. Change in magnetic flux induces the EMF. Change in magnetic flux induces the EMF. We know that the relationship between the magnetic flux and current. We know that relationship between the magnetic flux and current. So what is the relationship, guys? Flux is directly proportional to the current. Here current is related to the flux, means connected to the flux. Here current is related to the flux. Current and EMF is related. Then EMF is related to the flux. Electromotive force. It's like a voltage. So flux is directly proportional to the current. That's why flux is directly proportional to the EMF. Flux is directly proportional to the EMF. Here concept is change in flux. Change in magnetic flux induces the EMF. Change in magnetic flux induces the EMF. So Faraday and Henry do lot of experiments, then concluded change in magnetic flux induces the EMF. Finally concluded change in magnetic flux induces the EMF. So here we are taking one magnet, North Pole, South Pole. Then it is near to the coil, current carrying coil. Then this current carrying coil is connected to the galvanometer. Current carrying coil is connected to the galvanometer. See guys, here first, what is the use of galvanometer? Galvanometer gives the direction of the current. What is the use of galvanometer? Galvanometer gives the direction of current. Galvanometer gives the direction of current. So here we are using the galvanometer. This galvanometer is connected with the current carrying coil. When the magnet is near to the current carrying coil, then this magnetic field lines cuts the current carrying coil. When the magnetic field cuts the current carrying coil, the galvanometer either positive or either negative side, it will be deflect. This total is discovered by the Faraday and Henry. So all those things we will discuss in experiment 1, experiment 2, experiment 3. So flux either increase or decrease. Change in flux. Here flux is not constant, guys. See, when the change in flux is occurring, galvanometer is reflecting. The magnet is in stationary position. The galvanometer is in zero position. When the magnetic flux is changing, then only galvanometer is reflecting. It means what is the here change in magnetic flux induces the EMF. Constant flux is it does not induces the EMF. When the magnetic flux is changes, then only EMF will be induced. This total thing is discovered by the Faraday and Henry. Okay, here flux either increase or decrease, EMF will be induced. EMF will be induced. So Faraday and Henry do lot of experiments. In that, three experiments is the main experiments. First one is experiment 1. Here they are taking one magnet. Here they are taking one magnet. It is the magnet. See, from the magnetic field lines is producing. From the magnetic field lines is producing. Then the magnetic field lines is passing through the coil. Then the magnet, north pole and south pole magnet is moves towards to the coil. Moves towards to the coil. Then what is happening here? Maximum magnetic field lines or magnetic flux passing through the coil. So here magnet is moves towards to the coil. What is happening? More magnetic field lines is passing through the coil. More magnetic field lines is passing through the coil. Then what is happening? Flux is increasing. Then when the flux is increasing, the magnetic field lines is cuts the coil. Magnetic field lines cuts the coil. Then here current EMF is producing. Current and EMF is producing. We are identifying the current and EMF is inducing by the galvanometer. What is the purpose of galvanometer? It indicates the current direction and it indicates the current direction. It gives the direction means that some current is producing. That's why only it gives the direction. It means current is producing means EMF is also producing. You understand, guys? When the magnet is near to the coil, the magnetic flux is producing. That magnetic flux is cuts the current carrying coil. This current carrying coil it cuts the magnetic flux. Then the current and EMF is producing. Then the current and EMF is producing. How we are identifying? By the galvanometer. By the galvanometer. Oh, galvanometer deflects either positive or negative direction. It indicates the current producing. When the current is producing, EMF also producing. So I am taking now towards to the coil. I am taking the back roads to the coil and towards to the coil. So here magnet is near to the coil. Then I am taking away from the coil. Away from the coil. The magnet is away from the coil also. Galvanometer is deflecting in the opposite direction. Galvanometer is deflecting in the opposite direction. When the magnet is near to the coil, it deflects in one direction. When the magnet is away from the coil, it deflects in opposite direction. It deflects in opposite direction. It means flux is increasing or flux is decreasing. We are getting the deflection. We are getting the deflection. Again I am taking, so here south pole, here north pole. Here south pole and north pole. Then again I am taking a magnet is near to the coil. Near to the coil, galvanometer is deflecting. But in the opposite direction. Here from the north pole we are getting one direction means when here we are taking the south pole, it gives the opposite direction. It gives the opposite direction. Then the magnet is away from the coil, it gives the opposite direction. So you understand, guys? Yes. So magnet magnet near to the coil or away from the coil, EMF induces. EMF induces. EMF is induces. But polarities is different. Here we are taking North Pole, South Pole. Again in experiment, South Pole and North Pole. So here direction of deflection is different. Galvanometer deflection is different. As a positive or negative it is giving. But however, in that we are getting current and EMF. So magnet near to the coil or away from the coil, EMF is inducing. It means finally we are concluding flux changes. Flux either increase or decrease. Flux changes means either increase or either decrease. We are getting EMF. We are getting EMF. So you understand, guys. So Faraday and Henry done these experiments. Finally, they concluded flux changes. Flux changes. It will be either increase or decrease. It induces the EMF. It induces the EMF. This is the first experiment. Next, second experiment. This is the second experiment. Here, in the place of magnet, they are taking current coil. They are taking current coil C2. They are taking current coil C2. They are taking current coil C2. Then C1 coil C1 is connected to the galvanometer. Current carrying coil C1 is connected to the galvanometer. Then this current carrying coil C2 is connected to the battery. The current carrying coil C2 is connected to the battery. When the battery is connected to the current carrying coil C2, what will happen? What discovered? Any current carrying coil produces the magnetic field. Oersted already discovered any current carrying coil produces the magnetic field. So here we are connected to the battery. It means it is a voltage. When we are giving to the voltage to the current carrying coil, here current is passing through the coil. Then the current is passing through the coil. What is happening? Magnetic field lines is producing. Magnetic field lines is producing. That magnetic field lines is passing through the C1. When the current carrying coil C2 near to the C1, when the current carrying coil C2 is near to the C1, then what is happening? From the C2 coil, magnetic field lines is producing. That magnetic field lines is passing through the current carrying coil C1. When the magnetic field lines is passing through the current carrying coil C1, then what is happening? Galvanometer is deflecting. Galvanometer is deflecting. Galvanometer is deflecting. In both experiment 1 and experiment 2, the magnetic field lines is passing through the coil. Galvanometer is deflecting. But what is the difference? Here we are using the current carrying coil with the battery. There we are using the magnet. That is the difference between the experiment 1 and experiment 2. Okay, guys. Then here first in this first condition we are taking move towards to the coil C2. Then now I am taking current coil C1 is near to the C2. What is happening? Same here, magnetic field lines is passing by the battery. Then when the current coil C1 is near to the C2, also same condition. When it is near to the C2, what is happening? This magnetic field lines cuts the C1. Then galvanometer is deflecting. Then what is happening? Galvanometer deflecting means current is producing. Means EMF also producing. But here C2 and C1 is in stationary position. What is happening? EMF is not induced. It means coil C1 and C2 are in stationary position, EMF is equal to 0. This is the second experiment. Third experiment. So, see here guys, I am taking here also, they are taking there, here also same. Here also taking same, but here they are connected switch. When we are pressing and relieving the switch K, then what is happening? Continuously they are changing the switch position. Continuously they are changing the flux switch position. Then what is happening? From this coil's magnetic flux, from C2 to magnetic field lines is passing through the C1 coil. Then the galvanometer is deflecting. When the switch will be connected to the circuit, field lines is passing. Again it is removing, means it is in the opposite direction, also it gives the galvanometer deflection. When it will be closed at a certain time, it never deflects, means it is in the stationary position. When switch is continuously changing the positions, then only we are getting the galvanometer deflection. Switch is closed or switch is open, it gives the zero deflection. It means here flux is not changing. Means here EMF is not inducing. So switch position is in rest position. Or stationary position. Flux is not changing here. Then the flux is not changing. EMF is equal to 0. EMF is equal to 0. So from these three experiments, they concluded change in flux induces the EMF. Change in flux induces the EMF. So from these three experiments, they concluded change in flux induces the EMF. Next one, Faraday's law of electromagnetic induction. They introduced first law and second law. Faraday's first law and second law. Faraday's first law states that whenever change in flux, EMF induced, and then EMF lasts as long as change in flux continue. Already in first experiment and second experiment we proved change in flux produces the induced EMF. Change in flux produces the induced EMF. It means flux will be either increase or decrease. EMF induces. So what is the first law? Whenever change is a change in flux, EMF will induced, and that EMF lasts as long as change in flux continue. So there is a change in flux continuously, then EMF will be induced. But change in flux either increase or decrease. Anything will be happen, then EMF will be induced. Flux will be constant. Flux is constant. EMF is equal to 0. What is the second law? The EMF induced is directly proportional to the rate of change of flux in a loop. Already in first experiment, in second experiment, what is happening guys? When it is near to the magnet is near to the current carrying coil, the magnetic flux cuts the coil increasing. When it is near to the magnetic flux, means flux is increasing, then the EMF also increasing. It means change in flux will be increasing, EMF also increasing. That is the second law. Faraday's second law. The EMF induced is directly proportional to the rate of change of flux in a loop. Flux is increasing. Flux is increasing. EMF also increasing. From this definition, EMF is directly proportional to the rate of change of flux. The rate of change of flux. With respect to the time period, flux will be changes. With respect to the time period, flux will be changes. EMF is directly proportional to the rate of change of flux. The rate of change of flux. Then here I am taking EMF is like a E. Is like a E. Then E is equal to K into d phi by dt. d phi by dt. Here K is the proportional constant. Here K is the proportional constant. K is the proportional constant. Here I am considering K is equal to 1. Proportional constant I am considering as a 1. Then E is equal to d phi by dt. d phi by dt. d phi by dt. Now I am taking, see guys, here I am taking one magnet and then it is near to the current carrying coil. It is connected to the galvanometer. Here number of turns will be increases. Number of turns will be increases. The flux cuts the coil also increases. When here cutting of flux is increasing, when the number of turns is increasing, cutting of flux, change in flux is increasing. With respect to the change in flux, EMF also increasing. It means EMF is depending upon the number of turns of the coil. Yes, see, number of turns is increasing. Magnetic field cuts the coil also increasing. It means flux is increasing. Number of turns increasing, cuts the coil also increasing. From that, what is happening? EMF is increasing. It means EMF is depending upon the number of turns of the coil. Then EMF is equal to, EMF is directly proportional to the number of turns of the coil. Then finally equation is E is equal to N d phi by dt. But here minus N d phi by dt. Why we are taking minus? Why we are taking minus? This topic I will discuss in part 2. Why we are taking here negative? I will discuss in part 2. So what is the equation guys? EMF is equal to N d phi by dt is proportional to the N and d phi. Flux will be increased, EMF will be increased, number of turns will be increased, EMF also increasing. So what is the formula? From the Faraday's law, EMF equation is equal to minus N d phi by dt. Why we are considering here minus? We will discuss in part 2. From graph, how we will find out the EMF? From graph, I am taking flux and time period. It is a flux. It is a time period. From change in flux, I am getting some waveform. I am getting some waveform. I am getting some waveform. From this, for this waveform, I am taking tangent. One tangent I am taking. I am taking one tangent. What is the slope equation, guys? What is the slope equation? Slope is equal to d phi by dt. Slope is equal to d phi by dt. Slope is equal to d phi by dt. This slope we called as a EMF here. This slope we called as a EMF. We know that the rate of change in flux is equal to the EMF. So from the graph we will find out the EMF value. Next one, example I am taking here. So in this graph, in which point we are getting the maximum EMF. So we studied all those things now. Now, in which point we are getting the EMF, maximum value. See guys, from A to B, from A to B, any magnetic field lines is there? Any magnetic field lines is there? No. There is no magnetic field lines, then how we will get flux? There is no flux, how we will get EMF? No. From A to B position, there is no magnetic field lines. That's why EMF is 0. A to B, EMF is equal to 0. Then after that, see guys, B to C. B to C, magnetic field is changing with respect to the time period. Magnetic field is changing with respect to the time period. See, magnetic field is changing with respect to the time period. So what is the EMF condition? Change in flux induces the EMF. Here, magnetic field is changing means flux is also changing. There is a change in flux is there. EMF is producing. It means B to C, EMF is producing. So, B to C, EMF induced. What about C to D? See guys, from C position to D position, magnetic field is constant. C to D, magnetic field is constant. Magnetic field is constant means flux is also constant. So what is the condition guys? Flux, change in flux only induces the EMF. Here, field is constant, flux is also constant. When the flux is constant, EMF will be 0. So, C to D, EMF is equal to 0. Next, D to F, slope is like this. But here is, it will be this direction. Now it is in downward direction. Now it is in downward direction. Either increase or decrease flux, EMF will be induced. Either flux increase or decrease, EMF will be induced. But here is it is a decreasing order. So I am taking D to E. D to E, magnetic field is changing. Magnetic field is changing. There is a change in magnetic field. There is a change in flux. When the change in flux occurred, EMF will be induced. Next, E to F. So E to F also change in magnetic field. When the change in magnetic field is there, magnetic flux also changing. When the magnetic flux is changing, what happened? EMF induced. But my question is, where we are getting the maximum EMF? My question is, where we are getting the maximum EMF? What is the formula guys? E is equal to d phi by dt. E is equal to d phi by dt. It means within a less time period where we are getting the maximum flux, that point gives the maximum EMF. So in a less time period where the magnetic flux is changing more, at that point we are getting the maximum EMF. See here, B to C, there is a less time period, but the change in value is more. Maximum magnetic field is changing. See here, D to F, there is a maximum time period. That's why magnetic field is also changing. But here what is happening? In less time period, we are getting the change in value. Here it takes more time than it is giving the change in value. It is giving the change in value. So in this particular point, we are getting the maximum EMF. In this particular point, we are getting the maximum EMF. Here we are getting the maximum EMF. So you understand, guys? So from this example, you understand maximum total topic. Next one, EMF depends upon strength of the magnetic field, the speed with which the magnet is moved, the number of turns of the coil. See guys, I am taking one example. From two stones, I am rubbing more and more with more speed. With more speed, what will happen? Fire will be produced. No, I am taking like this. What is happening? There is no collision. The speed is very less. That's why at that point fire is not producing. Here also same. Speed will be increasing for the change in flux. EMF will be induced more. And one more thing, strength of the magnetic field. I am taking here more force. Then what is happening? Fire producing the less time period. Here also same thing. Strength of the magnetic field. B is increased. Magnetic field is increased, flux is increased. Flux is increased, EMF increase. It means, so flux is depending upon the magnetic field. More flux is passing through the coil, EMF also induced more. Next one, speed. Depending upon the speed also. When the magnet is near to the coil, it is connected to the galvanometer, it will be goes in a fast, when it will be fast like this, then what is happening? Cutting the coil is increasing, flux cuts the coil is very increasing, then EMF will be increased. Speed will be increased, flux cuts the coil also increasing, then EMF also inducing more. So EMF is depending upon the speed of the magnet position. Next one, depending upon the number of turns. Already I discussed, here the number of turns will be increased. Cuts the coil also increasing, change in flux also increasing, then EMF also increase. So EMF depending upon the strength of the magnetic field, speed with which the magnet is moved. Next one is the number of turns of the coil. That's why formula E is equal to N d5 by dt. But here we are considering negative also. Why we are considering negative we will discuss in part 2. So EMF is depending upon the number of turns and change in flux and with respect to the time period. So EMF is depending upon these three. So what about the resistance of the coil? So EMF is independent of the resistance of the coil. Which one is dependent upon the resistance of the coil? Current is depending upon the resistance of the coil. EMF is independent of the resistance of the coil. What is the relationship between the induced charge and change in magnetic flux? Today last topic it is. So we know that E is equal to d5 by dt. E is equal to d5 by dt. I am taking it is a first equation. Another equation also we know. Current is equal to EMF by resistance of the coil. We know that I is equal to E by R. E is the EMF. Then substitute that EMF in current equation. I is equal to d5 by dt by R. Then d5 by dt into 1 by R. I is equal to d5 by dt into 1 by R. And we know that I is equal to dq by dt. I is equal to dq by dt. This value substitute in this equation. dq by dt is equal to d5 by dt into 1 by R. dt cancel. Then finally we are getting dq is equal to d5 by R. Finally, we are getting dq is equal to d phi by r. dq is equal to d phi by r. So, relationship between the induced charge and change in magnetic flux. dq is equal to d phi by r. Change in flux is proportional to the change in charge and inversely proportional to the resistance. When the resistance will be increased, charge will be reduced. It will be reduced, it will be increased. Okay guys, today part 1 is completed. Next week I will come with remaining part, and one more important topic we will discuss next part 2. E is equal to minus n d phi by dt. That one we will discuss in part 2. Thank you guys.